Okay, we're going to learn how to dilate things today. Dilating things in geometry means very much the same thing as if we said that your pupils were dilated. When your pupils dilate, they get larger and they get smaller. Dilating isn't just getting larger. It can be getting larger or getting smaller. So we're going to start with number 1 here, which tells us to dilate triangle JFK. From center C, that's right here, that's important, and by a scale factor of 3. Okay, so 3 elements to this problem. The thing we're dilating, the center that we're dilating from, and then the scale factor. And so it's a fairly simple process. We always start from the center. Take any vertex of the triangle, start with any one that you want, I'll take the closest one, and count your way up and over from C to J. That's 2 steps up and 1 step over. But we want a new triangle, J prime, F prime, K prime, that's 3 times as large as this one. So it's going to be 3 times as far away from the center C. So rather than going up 2 and over 1, we're going to multiply each of those numbers by 3 to get 6 up and 3 over. So starting again from C and counting, this time we're going to go up not 2 times, but 2 times 3, which is 1, 2, 3, 4, 5, 6 up, and then 1 times 3 is 3 over. 1, 2, 3 over, and there it will be our J prime. If we do it correctly, then a line from the center through the original J should go right through the J prime. You don't have to draw that line. It's just a way of checking your work. If your J prime isn't on that line from the center through J, then you did something wrong. Now we just got to do this with the other 2 vertices and we're nearly done. So from the center again, so always starting from the center over to F, 1, 2, 3 over, and 1, 2 up. Multiply each of those numbers by 3. 3 times 3 is 9. 2 times 3 is 6. So we're going to go 9 over and 6 up, starting again from C, always starting from C. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 6 up. 1, 2, 3, 4, 5, 6. There will be my F prime because we just counted our way to F. So this will be an F prime. We can double check the work again. Does a line going from the center through F go straight through F prime? It sure does. You don't have to draw the line. It's just a way to check your work. Finally, from C to K, 1, 2, 3, 4 units over. I'll write that down here. And then 1 unit up. 4 right. I'm going to make a record of that down here. And 1 up. So now multiply each of those by 3, and we're going to go 12 right and 3 up, starting from the center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1, 2, 3 up, and that will be our K prime. Almost done, but not completely done until we connect J prime, F prime, and K prime to form our new triangle, J prime, F prime, K prime. And when you connect the 3 corners of the triangle, you have yet another way of visually judging whether you did a good job of this or not. The new triangle should look the same shape as the original triangle. All the angles should look congruent. It should look like it's facing the same direction, not rotated or reflected or spun around at all. And every new side of the triangle should look parallel to where it came from. J prime, F prime, doesn't that look parallel to JF? Of course it is. And F prime, K prime, parallel to this, and JK parallel to J prime, K prime. A good visual clue that we've done a good job. Now with this one, very much the same process. This time the scale factor is 1/2 and the center is P. But don't let the fraction throw you. The process is exactly the same. Let's count our way from P down to C. 1, 2, 3, 4, 5, 6 down, and 1, 2 over. Multiply each of those numbers by the scale factor, just like we did over in this problem. We multiplied every number by 3. Every distance we multiplied by 3. And we're multiplying every distance here by the scale factor. Even if it's a fraction, don't let that throw you. If you need a calculator to do it, grab a calculator. 6 times 1/2 is 3. 2 times 1/2 is 1. So let's start over. From P, instead of counting our way down 6 and over 2, we're going to go down 1, 2, 3 and over 1. And there's the P prime. Notice it's gotten closer to the center than, oh, I'm sorry, that's not a P prime. That is a C prime. We took the original point C and made it closer to the center of dilation. When your scale factor is a number bigger than 1, then when you multiply numbers bigger than 1, those numbers get bigger and the triangle gets bigger and it gets farther away from the center. When you're multiplying by scale factors that are less than 1, the numbers that you're multiplying get smaller, the triangle is going to get smaller, and everything gets closer to the center. Let's do that with point Q. 1, 2, 3, 4, and 2. 4 up and 2 over. Multiply each of those by 1/2, and we'll get 2 up and 1 over. Start from point P all over again and go 2 up and 1 over, and there's your Q prime. And we can check that we've done these correctly same way we checked the previous problem. Draw a line straight from P to the original point C, and it should go right through the new point C prime. And it does. Here's that line from P to the original C. It goes right through C prime. Here's a line from P to the original Q. Look, it's going to go right through Q prime right there. So it's looking good. Finally, from P to V, 1, 2, 3, 4, 5, 6 over and 2 up. Multiply each of those by 1/2, and we get 3 over and 1 up. 1, 2, 3 over and 1 up, and that point is right on a line from P to V. There's the V prime. Connect Q prime to V prime to C prime, and it should look just like the original triangle, only smaller. Okay? This side's parallel to this side's parallel to that, this side is parallel to that. Everything looks good. Moving down to numbers 3 and 4 at the bottom of the page. If triangle FTT is dilated, so this almost seems to suggest that we don't have to do it. It just says, what if we did? And we dilated from the origin. The origin is at 0, 0. So that's going to be our center of dilation this time. And if we dilated by a scale factor of 9, so the original triangle is going to become 9 times as big as it is right now. I don't think we even have room to do that on this paper. That's why the problem says if we did that to produce a new triangle, F prime, T prime, D prime, what would be the coordinates of the new points? Again, we don't have room to actually do this, but when you are dilating from the origin, there's a real easy way to find the coordinates of the new points. I have on the grid here the coordinates of D at 1, 2. If we're dilating from the origin, and D is 1 unit to the right of the x-axis, the new triangle is going to be 9 times that far to the right. So 1 times 9 is 9. And then the y coordinate is going to be 9 times as high as the original y coordinate. 2 times 9 is 18. That's all there is to it. Multiply the original coordinates by the scale factor, and you have the new coordinates. So if f is at 2, 10, f prime will be at 2 times 9 is 18, and 10 times 9 is 90. T's original coordinates are at 12, 9, and so T prime will be at 12 times 9 is 108, and 9 times 9 is 81. That's where the new coordinates would be. This multiplying coordinates by the scale factor only works when dilating from the origin. This is so important to remember. Only when dilating from the origin. You can't do this up here and expect to be able to find the locations of new coordinates. You got to do these problems the way we did these problems. But here we can just multiply. Do the same thing. Don't be thrown by a scale factor that is a fraction in the next problem. We'll do the exact same process. And if you need your calculator, grab your calculator. So point W is at 12,6. Where will W prime be? Multiply the 12 by a third. That gets you 4. Multiply the 6 by a third. That gets you 2. There's your W. Take E, which is at 18,12. Multiply each of those numbers by a third. You get 6,4. Take S. Multiply each of those coordinate values by 1/3. And you get 5,0. Now this one we actually have room to put on the grid. So I'm going to go ahead and do it just to see if it looks right. So W prime is at 4,2. That's right there. And E prime is at 6,4. That's right there. And then S prime is at 5,0. That's right there. And if I connect those 3 points, doesn't that little triangle look just like this triangle over here, only smaller and a lot closer to the center of dilation? Not only that, if I draw a line from the center of dilation to the original S, it goes right through S prime. If I draw a line from the center of dilation to the original W, it goes right through W prime. And if I draw a line from the center of dilation to the original E, it goes right through the E prime. Everything checks. Let's go over to the back side. Here we don't have a grid, so we can't do any counting and multiplying. Okay? But that's why this problem says dilate this triangle JFK from center C, I'll zoom in on that a little bit, using a compass and a straight edge or a ruler. I'm okay with the ruler. So here's what we know. If the scale factor is 3, then we're going to get a triangle that is much bigger than the original. And if the center is C, everything is going to get much farther away from C. I'm going to begin by drawing lines from the center. Just like I was doing to check my work on the front side of this page, we're actually going to use to do the work on this side. So I'm going to draw a line from C through J because I know J prime has to be on this line somewhere. And then the other thing I know is that it has to be 3 times as far away from C as the original J. So I'm just going to measure that distance with my compass. I think this is easier to do with a compass than a ruler. Okay. There's 1 time from C with my compass. Now move the compass point down to J. Make an arc. There's 2 times. And then move my compass point down to that spot. And move the camera over a little bit and finally make a 3rd arc. That's where the J prime has to go. Here's 1, 2, 3. That's where my J prime is. I know it's in the right direction because I drew the line ahead of time, going from the center through J. And it's 3 times as far as the original. 1, 2, 3. Do the same thing with K. Draw a line from C through K. I know the K prime has to be somewhere along this line. Measure the distance from C to K. Got to widen that compass just a little bit. Shrink that up a little. There we go. There's 1, 2, and 3. And there's my K prime right there. Let's do this one more time with point F. Move that compass over a little bit. Draw a nice long line through C, the center, and F. I know my F prime has to be out there somewhere. Measure the distance from C to F. There's 1, 2, 3, and there is my f prime. Finally, take that straight edge and connect all the new points with each other. Boy, I can barely see that on the camera. The j prime to the k prime and to the f prime. Got just enough room for it. There's j prime, k prime f prime, and f prime to j prime. My straight edge doesn't quite reach that far. I'll do the best that I can. Yeah, I didn't do a great job there. Okay, that should connect up. But still, doesn't it look like f prime j prime is parallel to the original fj? Doesn't it look like j prime k prime parallel to the original jk? And then also over here, k prime f prime parallel to kf? Should look that way if you've done a good job. Finally, number 6. Here, we're not being asked to do a dilation at all. This is telling us that triangle HAM, that's this one, has already been dilated. Oh, and reflected, by the way. It looks like it might have been reflected over that line, so that this got flipped over upside down there, but then dilated to be made bigger to produce this new triangle H prime, A prime, M prime. This time we're being asked to find the scale factor. In all the previous problems, you were given the scale factor. This time we're trying to find the scale factor, which is quite easily calculated by dividing a prime value by an original value. In other words, go to the triangle with the primes in it. This is the newly created triangle. This was the original, this is the new one. Take some side length from the new triangle, any one of them. Okay? If you don't like decimal numbers, pick another number, 150. And then divide that value by its corresponding value in the original triangle. You got to match up sides properly. Clearly A prime M prime matches up with AM. So we must divide the 150 by the 60. Or another way to recognize it is that this is the largest number in this triangle. Okay? It must correspond to the largest number in this triangle. 150 divided by 60 is 2.5. There's the scale factor used in the dilation. Okay? You calculate this value, listen please, not by always dividing a big number by a small number, not dividing by the number on bottom, by the number up above, or the number on the right, by the number on the left. It's always, always, always a number in the prime triangle by a number in the original triangle. Always in that order. Sometimes it'll be a large number by a small number, and you'll get an answer bigger than 1. Sometimes it'll be a small number by a large number, and you'll get an answer less than 1. We should expect, before we even did a calculation here, we should have expected to get a scale factor bigger than 1, because clearly HAM had to grow larger to become H prime, A prime, M prime. The only way things get larger is when the scale factors are bigger than 1. That's the notes for today. Good luck on the homework.